All right, let's dive into one of the coolest aspects of radio technology, radio wave propagation. So, if you've ever wondered how sounds travel from a radio tower all the way to your car or that old radio at home, here's the lowdown. Radio waves generally travel in three main ways: line of sight, ground wave, and sky wave. Think of line of sight as the most straightforward. It's like drawing a straight line from the transmitting antenna to the receiving antenna. For example, FM radio and satellite communications rely heavily on this method, but here's the catch. Line of sight works best when there's nothing blocking the way, like mountains or buildings. Now, ground wave propagation? That's a little different. This type of wave actually hugs the Earth's surface and follows its curvature. It's how AM radio stations, especially at lower frequencies, reach across vast distances. That's why you can sometimes listen to an AM station broadcasting far from home. It's pretty amazing how these waves just, cling to the ground and keep going. And then there's skywave. This one's really fascinating because it uses the ionosphere, a layer of charged particles way up in the atmosphere, to bounce signals back to Earth. Back in the 1920s, radio enthusiasts discovered that medium wave and shortwave signals could travel thousands of miles this way. This revolutionized worldwide communication and was even used in some early long-distance broadcasts. Imagine shooting a signal into the sky, and it comes back down to reach the other side of the planet. That's skywave for you. But it's not always smooth sailing. Atmospheric conditions can drastically affect signals. For instance, the ionosphere's density isn't always stable. It changes based on solar activity, time of day, and even the seasons. That means one night your favorite station might come in crystal clear, and the next it's, kind of fuzzy. Now let's talk challenges, especially for those of you living in urban areas. High-rise buildings, dense neighborhoods, and even weather can interfere with radio signals. You've probably experienced this with your car radio when driving in a city, where signals suddenly cut out or get mixed up with other stations. These obstacles can block or distort waves, making reliable communication tricky at times. But despite these challenges, radio wave propagation remains one of the most fascinating aspects of modern communication. Understanding how these waves travel, and how conditions can change them, gives us a glimpse into the powerful and dynamic world of radio. Pretty cool, right?